Project 3 is going to give you the opportunity to play with real data and the normal distribution to calculate some probabilities. For this project, these instructions are very important. First, you're going to click this link for the NASDAQ Historical Prices web links, and if you hit Control while you click on it in your document, it will open up the NASDAQ's closing values for the past year or so. You're going to change the dates here and here to match the dates for the project, and then click Update. Once you update, you're going to click the Download to Spreadsheet option, and then you're going to use that as you work through the project problems. Now for those dates, this is very important. You're going to set those dates for exactly 1 year ending on the Monday this course started. For example, if this course started on April 1st of 2014, the starting date you will use is April 1st of 2013, a year ago. And then you'll go to the day before, March 31st, 2014. So there's 1 year in there. There won't quite be 365 values because the stock market gives no values on weekends and holidays, so a lot of values will be missing. But that should give you about 250, 255 or so values in your spreadsheet. For this project, we are only going to use the closing values, so you can ignore all the other columns. And this is very important. We are going to assume the closing prices of the stocks form a normally distributed data set. We're going to use the normal distribution, its formulas, and its tables and Excel features in order to answer all the questions. Basically, we're going to use everything you learned in 5.2 and 5.3 for this project. So to calculate probabilities, you should never be counting data points. If you are counting data points to say, hey, there's 72 out of the 250 values that fall, you're doing it wrong. You're not going to get any points. Do not count data points. Use the formulas for the normal distribution. The other really important thing, as you complete this assignment in that Excel file, you need to show your work on how you got all of your answers. No work, no credit. Lots of students lose points because they don't show me the work. Show me the work, explain your process. That's very important. It's better to give too much information than not enough. All right, let's get into the questions that you're actually going to answer. First, you need to make sure that you submit your data set along with the file that contains all your answers. Most students, and I recommend this, just make it all one document. The same document that has the data set you downloaded, work in that document to calculate your answers. Then you can use Excel to find the mean and standard deviation. And then you're going to consider, if a person bought 1 share of Google stock in the last year, what's the probability that closes at less than the mean for the year? In fact, you don't have to do any calculating for C. If you think about what we know about the normal distribution, you should be able to tell me, for any normal distribution, what percent are less than the mean. Number 2 is where you actually start using the data. We're going to say if a person bought 1 Google stock within the year, what's the probability it closed at more than, and then your project is going to have a number there. We update that number every year, so I'm not putting the number in this video. This makes it easy for me to see if a student copied a previous term's assignment because the numbers change from term to term. Make sure you check what number your project puts in there and give me the probability that Google closed higher than that value. Then we're going to see what's the probability that the stock closed within a certain amount of the mean for that year. That means I want you to take this value in number 3 and add it to the mean, subtract it from the mean, and tell me what is the probability that you're within those two values, in between those two values. Number 4 says somebody tells you they bought some Google stock for another value, and you're going to decide, is that unusual? Please use the definition of unusual from your course textbook. There was a definition that had to do with standard deviation. I recommend you use that one, but both definitions your textbook give you will be just fine. Then you're going to be asked to go one step further and say, on number 5, at what price would Google have to close for it to be considered unusual? What's the lowest value? What's the highest value before it is considered unusual? Using that same definition for unusual. And again, the standard deviation definition is probably the easiest. Number 6 asks you to have Excel calculate quartiles 1, 2, and 3. And then number 7 wants you to think about, based on those quartiles, and also if you make a histogram of the data with maybe 10 to 12 classes, was our assumption at the beginning that this is a normal distribution accurate? Why or why not? It's important to remember for number 7, real data is never perfect. In statistics, we're always content with close enough. But if it's not close at all, it won't work at all. So yes or no, is it close enough to be valid? Or no, this really doesn't look like a bell curve normal distribution at all because the quartiles did this or because the graph did that. Tell me why you think that. The final 5 points of the project are going to come from things like using the correct dates, the correct mean, the correct standard deviation. And again, as usual, the project is due on Monday. If you have any questions, go ahead and send me an email. Good luck.